Based on the condition discussed in the previous video of improper integral, now we will divide the improper integral into three kinds: improper integral of first kind, improper integral of second kind, improper integral of third kind. So we will divide the improper integral into three kinds, and the characteristics for dividing these three integrals are based on the either of the limit is finite or infinite, or function should be bounded or unbounded. So, so based on these characteristics, we will divide the improper integral into three kinds. So let us see what is the improper integral of first kind. So improper integral in the first kind, either of the a or b, either of the a or b. So either of the a and b, or both a and b. So here it says like we can consider infinity to 0, minus infinity to 0, 0 to infinity, or minus infinity to infinity. So either of the limit a or b, or both are infinite, but f should be bounded. So here in this case f cannot be unbounded. In this case f should be bounded, but either of the a or b, or a and b, are infinite. So let us see the example for this. So if we consider 1 to infinity dx by x, so here we can see that this limit is infinite, but if you calculate any c x tends to c, 1 by x, this should be any finite value. C can be take anything from 1 to infinity. So it means what? It means fx is bounded here. Fx here is bounded. So in the improper integral of first kind, what we see either of a or b, or both a and b is infinite, but function is bounded. It is important here that function should be bounded. Let's see one more example for improper integral of first kind. So let's consider minus infinity to 0 e to the power x dx. Okay, so we can see that one of the integration is infinite, one of the integration limit is infinite, and if you consider ex, if you consider the function fx, so this is fx is bounded, fx is bounded in the interval of minus infinity to 0. Okay, so we can see that by the graph also. So e to the power x graph is like this. In 0 its value is 1, and after that it will goes to infinity. So if we consider minus infinity to 0, this function is bounded. This function is e to the power x is bounded. So this is another example for improper integral of first kind. Now let's discuss the improper integral of second kind. So in this second kind, both a and b should be finite. A and b should be finite. Instead of improper integral in first kind, either of a or b, or both are infinite. So this is the difference between improper integral of first kind and second kind. Here a or b are infinite, infinite, or both a and b are infinite. But in the case of improper integral of second kind, both a and a and both a and b should be finite, should be finite. Okay, so this is the difference between improper integral of first kind and second kind. In this, the, the second case is here is f should be bounded, f is bounded, f is bounded. But in the improper integral in second kind, f is not bounded, f is not bounded, bounded on closed interval a to b. These are the two difference between improper integral of first kind and second kind. Now let's see the example for improper integral of second kind. So first example is integration 0 to 1 dx upon x square. So here you can see that these two limit a and b are finite. Here these two a and b are finite, but the function fx is equals to 1 upon x square in the neighborhood of 0, it means limit extending to 0 fx is not bounded, not bounded. So in this example, we can clearly see the limit is finite, integration limit is finite, but the function is unbounded. Most precisely, in the neighborhood of 0, in the neighborhood of 0, it is unbounded. It is unbounded. Okay, so this is the example for improper integral of second kind. Second example can be considered as 1 to 2 dx upon x minus 1. So here we can see that this limit is finite. Here the limit is finite. Here the two limits are finite. Lower limit and upper limits are finite, but function fx is 1 upon x minus 1, which is which is unbounded in the neighborhood of 1. In the neighborhood of 1, this is does not exist. Does not exist. One can also see the example like 1 to 2 dx upon x minus 2. So here what we are doing actually, we are making unbounded for some points. Like here it is unbounded for 2. So this is the example for second kind, because we are considering the limit are finite. Integration limits are finite, but we are considering this function is unbounded. This function is unbounded, most precisely in the neighborhood of 2. So this is improper integral of second kind. These are the examples. One can also make function to be unbounded in both of the limit point, both of the integration limit points. So we can construct like 1 to 2. So if we want function be unbounded in the point 1, so we can take x minus 1. And if we also want the function is unbounded at 2, so just multiply it with x minus 2. So this is the example for improper integral of second kind, where a and b are two finite value, but function is unbounded. Function is not bounded at x is equals to 1 and at x is equals to 2. These are the examples for improper integral of second kind. You can make many more examples for improper integral of second kind by making function not bounded, and both a and b are finite. By taking a and b are finite, let's come to the improper integral of third kind. So in this improper integral of third kind, what we do, interval of integration should be unbounded. That means one of the limit should be not finite, like minus infinity to 0, 0 to infinity, or minus infinity to plus infinity. So you can make any of the interval of integration should be unbounded, or fx should also be unbounded. So with that, you have to construct this fx should be unbounded. This fx should be unbounded.